Hello, everyone, and welcome back to Math Zone African Motives. I hope we are all fine and we are doing well wheresoever we are. I want us to continue with our great core physical sciences, where we have been discussing on a topic momentum, rate of change of momentum, Newton's second law in terms of momentum, impulse, and collisions. But today, I want us to specifically discuss on the subtopic rate of change of momentum. And then we would then further also look into the what? Into Newton's second law in terms of momentum. And we will simply look into impulse. And then the next coming videos would be on what? On collisions, where we are now going to be looking into types of collisions in terms of elastic and non-elastic collisions and how we get to solve or else work out problems in regards to these types of collisions. So without wasting time, let's get started. So what is it that we refer to as a rate of change of momentum? So maybe before we start looking into rate of change of momentum, let's go back to what we termed change in momentum. So we said momentum is the product of mass and the velocity of the object, which means that change in momentum will now become also what? Final momentum minus initial momentum, where we know that we have actually said that momentum is given by what? By mass and velocity. So this would be mass times final velocity, because we said mass remains constant, minus mass times initial velocity. And this led us to say that change in momentum is also equal to, when I factor out my mass, since it will be constant, I'll be left with final velocity minus initial velocity. So this becomes my change in momentum. Now I want to see how this change in momentum actually change with time. So this is where we are now saying that this is this is where now we are now saying what is the rate of change of this that we are referring to as what? As change in momentum. What we are saying it's change in momentum. We want to look into how quickly an object's momentum changes with time. So the rate of change of momentum can be given by what? It can be given by change in momentum over the time taken to change that momentum. So this will simply fold to what? To our mass times final velocity minus what? Initial velocity, all over the time taken to change that momentum. That becomes our rate of change of momentum. And that is how we can be able to calculate our rate of change of what? Of momentum. And this would be in the same direction as the direction of what? Of our momentum. Now, delta P represents change in momentum, whilst delta T represents the time interval in which our momentum changes. So what this simply refers to, or else what it means, is that a larger force causes a rapid change in momentum, whilst a small force will cause a slower change in momentum. What are we saying? Let's go to what we call our Newton's second law of motion in terms of momentum. Then we can be able to go back to what we have said there. So we can see that our Newton's second law of momentum can be used to find the object's acceleration due to the net force, as well as the object's change in momentum due to the net force. So let me take you back to our Newton's second law. We know that Newton's second law is given by this formula, where we are saying net force is equal to mass times acceleration. But also from our grade 10 and grade 11, we know that acceleration is given by final velocity minus initial velocity over the change in time, which is over the time interval. So if I'm to take this and substitute it here, where I'll replace acceleration with this, then this can also be given as final velocity minus initial velocity all over the time interval. By doing that, we can state our second law in terms of what? Mass times final velocity minus mass times what? Initial velocity over the change in time. Where we see that whatsoever is above there, which is on the top, is simply what we are saying is our change in momentum. And this becomes the rate of change in momentum. Hence, therefore, we can now simply get to say that also our net force can be given by the rate of change of momentum from Newton's second law. So our Newton's second law can also be expressed as the rate of change of momentum. So this is how we can also get to write our second law of, this is how we can simply write our what? Second Newton's law. So we have now expressed our second Newton's law in terms of what? Of rate of change of momentum. Hence, therefore, we can now get to determine our acceleration of the object in terms of the net force, as well as determine our rate of change of momentum in terms of the net force. So this is what we have been explaining here, where we are saying that we can be able to say, we can use the Newton's second law of motion to determine the object is what? Is acceleration due to the net force, as well as the object is change in momentum due to the net force. This is where we would say net force is equals to mass times acceleration. As well as we can also get to say net force is equal to rate of change of what? Of momentum. We have determined this from this. So what it simply means is that Newton's second law states that the net force acting on an object is equal to the rate of change of momentum of the object. This explains to us why it is important to use foam rubber carpet when we are doing our what? Our high jump. So we are saying that this is why it is less painful for a high jumper to land on a foam rubber carpet than to land on a what? To land on the ground. How so? Let's go to the principle of what? Of impulse, or else what we are referring to as impulse. So impulse is simply the product of the net force acting on an object and the time interval during which the force acts. So impulse can be given by what? By net force times the rate of change of what? Of oils times the what? The time interval. So we are saying that net force times delta t is equal to change in momentum. But this is what we are referring to as impulse. Therefore, this explains why increasing the time of impact reduces the force experienced by the object. Let me explain this using what we have just said here. So we are saying that if you are having net force being equal to the rate of change of your what? Of your momentum, what you are saying is this: when my time increases, when this time interval, when the time interval increases, when the time interval increases, then it simply tells us that our net force is going to decrease, because we are seeing that here, once this time interval becomes small, then our net force will what? Will increase. The total here will increase. When this time interval becomes small, then this whole expression will increase. But when our time interval increases, then the net force reduces. So you would see that by decreasing the time that you need to land down, you are increasing the force of impact. Therefore, if you increase that force of impact, you would actually get to increase the damage that would occur on you. Therefore, this is the reason why it will be more painful to land on the ground, because when you are landing on the ground, the time interval that it takes to land on the ground is small. But when you are now landing on your what? On your foam rubber carpet. Let me just give an example to say that this is the foam rubber carpet. The high jumper who is jumping from a certain height would actually take a longer time to reach the ground, because this foam rubber carpet would actually get to what? To absorb him, or else it will actually get to contain him, or else what can I explain here? We are saying that once you land on this foam rubber carpet, the sponge of the foam rubber carpet would actually carry you through up until you reach the ground. So you are not going to reach the ground instantly, but it will take a longer time for you to actually get to what? To reach the ground. So that longer time is reducing the what? This reduces the force of impact. This reduces the force of impact. So the lesser the force of impact, and then the lesser it is painful for you. Or else, let's get to say that once we have reduced the force of impact, this reduces the pain that you are going to what? To experience. So this is why we would go back and say that it is less painful for a high jumper to land on foam rubber carpet than on the ground. And this is the same concept that comes into play when we talk of airbags, as well as what? As well as safety belts. So you will see that airbags are actually increasing the time interval in which you would actually hit on your steering when your car experiences a what? A collision. So you would feel less pain. This makes you feel less pain. Why? Because they prolong the time of impact. These prolong the time of impact. So these prolong the time of impact. So once we prolong the time of impact, then we are reducing the pain that you are going to feel. So this is simply the explanation that comes with our airbags and our safety nets, as well as our what? Is our foam rubber. So this is how we explain our rate of change of momentum. And this is why it is important to study the rate of change of momentum. And this is how you would simply explain it using Newton's second law. So impulse helps us to explain why we would need airbags and why we would need safety nets. And I've explained that they prolong the time of impact. Once we prolong the time of impact, we are increasing the time of impact. This is when we increase the time of impact, we reduce the force of impact, or else the force experienced by the object. That force is the one that causes pain. So by reducing the force, we are reducing the pain that is experienced by the object. So this is what I wanted us to explain in this lecture. So thank you so much, guys. Let's meet in our next lecture, where we will be now looking into the conservation of linear momentum. We are going to be looking into the principle of conservation of linear momentum and the different types of what? Of problems in which we will apply that conservation principle.